All right, welcome back. In this video, we're going to go over alkenes. So here is the agenda for this video. We're going to first talk about what alkenes are. Then we're going to go over how to name and number them. Then we're going to do some practice problems. Then I want to talk about cis and trans, the sexual identities of alkenes. I'm just kidding. Okay, yeah, cancel me. And then we're going to talk about the more substituted alkene. Well, this right here is the really important thing that I want you to learn, because this is important for E2 and E1 reactions. I've been saying that the E2, E1 reactions are going to be the next video, blah, blah, blah. I was just looking at my agenda now. It is officially the next video. So, but I need you to know this for that. And then, yeah, that's going to be it. It's going to be a nice, easy video. Also, on other news, I am very close to 100,000 views, so thank you so much. I am like 800 away, or 700 away, or 600 away. I'm some number away from 100,000, so thank you so much. All right, let's do this. What are alkenes? Alkenes are basically double-bonded carbon atoms. Alkanes, which we were previously dealing with, are single-bonded carbon atoms, where alkenes, with an E, is double-bonded carbon atoms. And why were you learning this? What's the point? Am I just here to torture you? Yes, but the reason we're learning this is because elimination reactions, E2 and E1, create double bonds. So if we're creating double bonds, we should really know how to name them. Don't you think? It would be a good idea. So, here, I have an example. On the left-hand side here, we have a pentane, right? Pent means 5. So this is a pentane, 1, 2, 3, 4, 5 carbons. And ane, the suffix, means it's an alkane, or single-bonded carbons, no double bonds. On the right here, we have pentene. Pentene, the suffix ene, tells us we have an alkene, or a double-bonded carbon somewhere in the compound. This double bond is also known as a pi bond for a bunch of other reasons you don't really care about, or I don't really care about. It's just a bunch of jargon, so don't really worry about that. Now, there's also alkynes. Alkynes is a triple bonded carbon, which we're going to get much later on in organic chemistry. So don't worry about that. All right, naming and numbering. To do this, the first thing you must do is find the parent chain. That is the chain with the most number of carbons. Now, this must include the alkene, or the double bond. Even if you find a chain that is much longer, but does not include the double bond, that's illegal. That's not good. We don't like that. It must include the alkene, even if it's a shorter chain. So here's a good example. Here on the left, I am saying that the parent is octane, or 8 carbons long. 1, 2, 3, 4, 5, 6, 7, 8. This is wrong because it's not including the double bond that's here. However, if I number like this with the double bond being included, 1, 2, 3, 4, 5, 6, 7. Yeah, it is 7 carbons long, so it is shorter than this, but this is correct. This is wrong because this is including the alkene, the double bonded carbon. All right, numbering alkenes. Alkenes must be assigned the lowest number. Here we have 2 examples. Here I am numbering the alkene, giving the double bond carbon number 2 and carbon number 3. Compared to something like here, where I number from the opposite end, from right to left, giving the alkene carbon number 5 and 6. This is wrong because this needs to be the lowest number possible. The alkene must be as low as possible. Oh, I give the answer away. Oh, shit. Okay. Whoops. Okay, so here's the thing. Is that I record these videos a few times in practice. Right? I do it like maybe 3 or 4 times until I can get it right. Because everything I do, I improvise. Everything I say is improvised. I don't write anything down. I have no script. So I was recording this. I messed up. And so that's the reason, okay? But it didn't tell you the full answer, so it's fine. We're chilling. We're fine. All right, so name all the functional groups and branches. Damn, I'm an idiot. Okay, name all the functional groups and branches that come off the parent chain. Then list the alkene location with the respective carbon number. All right, so what do? Well, like I said, the first thing you do is number this parent chain. We're not going to number it from right to left, right? Like this 1, 2, 3, 4, 5, 6, 7, because this gives the alkene carbon 5 and 6, and that's too high. Whereas we can just do this, number it from left to right, and give the alkene the lowest number. Now I can either name this 7 or this 7. It does not matter because we're going to get the same answer. I'm just going to name this 7. Okay, now we need to identify all the substituents coming off of the parent chain, or all the branches, and name them. So here we can see that on carbon 5 we have 1 branch and 2 branches. This is 2 methyl groups. So here's what I'm going to do. I'm going to write on carbon 5 we have 2 methyls. On carbon 6 we have a methyl, right? Because remember, this is a CH3 group. This is a CH3, this is a CH3, this is a CH3, right? They're not hydrogens, they're carbons there. And so we're going to write on carbon 6, we have 1 methyl. Okay? So 2 plus 1 equals 3. So you have 3 methyls in total. Also known as, so let's do some math here. I hate math. So hard, right? So 3 methyls. 3 in organic chemistry is tri. Okay? So we have trimethyl. So 3 methyls in total. So now what do we do? Well, what we need to do is now name this molecule by first listing where the substituents are located at. So remember, when we separate numbers with numbers, we use a comma. But if we separate a number and a letter, or a letter and a number, it's a hyphen. So this is going to be 5, 6. Trimethyl. Right, so once again, I'm saying that we have a methyl group located on 5, a methyl group located on 5, and a methyl group located on 6, which is 3 methyls. So it's a trimethyl. And now what we need to do is identify where the alkene is located at. We must list it with the lowest number of carbon possible. So what is technically, yes, it is on carbon 2 and 3, but we only care about the lowest number. So it's on 2. So we separate, because now we have a letter, right? This is an L. So now we use a hyphen. We put a 2, and then we put a hyphen. And we put the parent chain ending with -ene at the end. So this is a 7 carbons long, so this is a hept. And since we're dealing with an alkene, it's heptene. And that's our answer. All right, let's do some practice. What do we do here? First thing is list the parent chain. So number it. So it's going to go 1, 2, 3, 4, 5, 6. Now you're maybe wondering, can I number it the other way around? What if I do this? 1, 2, 3, 4, 5, 6. What if I do this? You'll notice on both ways, both directions I go, the double bond is on carbon 3, right? It's 3 here and 3 here. But which way is correct? There's only one correct way. The correct way would be making the substituent the lowest number possible. So this is a really good example for an exam. If you number this molecule both ways and you realize that both ways will give the alkene the lowest number, then you must make sure the substituent now has the lowest number. So now if you look at this way, you'll notice the substituent, if you number from left to right, the substituent will be on carbon 3. But if you number from right to left, the substituent will be on carbon 4, which is not good. It's not allowed. So we're going to erase this, and we're going to number it like this. 1, 2, 3, 4, 5, 6. That's the correct way. All right, so now we have a methyl on carbon 3. So let me just document that here. A methyl on carbon 3. And that's it. That's all we have. So what we're going to do is label this or name this 3-methyl -3-hexane. hexene, sorry. Because the 3, corresponds with a double bond. That's where it is. And we put the lowest number possible. It's a 6 carbons long hex, and ene telling us that we have a double bond here. How? Okay, so imagine this. What happens if this ene wasn't there? How would we know that there's a double bond in this compound? This is how. Right? If I were to put this as ane, for example, then I would think this is a single bonded compound here with no double bond, right? But it's ene. All right, now we get some more complicated stuff here. What about this one? All right, so I can start off numbering from either here, here, right? It does not really matter which branch I start off with, but let's just do, let's start off with here. 1, 2, 3, 4, 5, 6, 7. I can go either way. I'm gonna go down here. 8. Okay. Here's a good question. Can I name it going the other way? Say if I go 1, 2, 3, 4, 5, 6, 7, 8. Well, you'll notice that the alkene is both on carbon 4, so it's both at the low end. But there is a problem. What is the problem? Why can I not go that way? The reason is because you'll notice that we have 2 methyl groups on carbon 2 here. So it's going to be, so let's just say this. We have 2 carbons coming off of, 2 methyls coming off of carbon 2, and then we have 1 coming off of carbon 7. So I could do this as 2, 2, 7 trimethyl, right? Or if I do it the other way, it would be 2, 7, 7 trimethyl. Right? If I were going off the numbering, going from right to left, right? 2, right, which is here, then the 2 methyls here on carbon 7 trimethyl. This is why we cannot have. If you look at the numbers, right? This one's lower than this one, right? We have 2, a 7, and a 7. That's higher than a 2, 2, and a 7, right? You could just add these number up. You could just do you know what I mean, right? Like if you were to add these up, you'll notice that this would be higher, right? So this is wrong. Sorry, I was stuttering there. It's kind of hard to explain, but hopefully you understood that. So now we have to identify the substituents. We have, what do we have here? We have carbon 2. And then we have 2 methyl. Carbon 7, we have 1 methyl. On carbon 4, we have ethyl group. 1 ethyl. On carbon 5, we have 1 ethyl. And then our alkene will be on carbon 4. And that looks like it's it. Yeah, okay, so how do we name this? Well, let's start with alphabetical order. So the ethyls come first because it's in alphabetical order compared to a methyl, right? E versus M. So ethyl wins. So we must name it 4, 5 hyphen dimethyl. Right, because 2 ethyls is a di. Oh, di. Whoops. Oh. Diethyl. Like that. Diethyl. Now we have to deal with the methyl groups, right? So we separate it with hyphen. It's going to be 2, 2, 7. 2 methyls on carbon 2 and 1 methyl on carbon 7. 2, 2, 7. Hyphen. Trimethyl. Because we have 3 methyls in total. Hyphen 4 octene. because the carbon chain is 8 carbons long, and E telling us the alkene double bond is located at carbon 4. Okay, what about this one? So this one is going to be 1, 2, 3, 4, 5, 6, 7. All right. What do we have here? We have, let me write it here. We have 2 methyls and carbon 2. So carbon 2, 2 methyls. We have 2 methyls and carbon 5. I should say, you know what? We have 1 and 4 too. I did not see that. Okay. Let me do 4. Right, 4. 1 methyl. 2 methyls. Okay. And that's all the methyls I see. So this is going to be 5 methyls, or pentamethyl. And then we have an ethyl on carbon 3. Right, this is an ethyl group. 1, 2, that's an ethyl. Okay. And so we are done. So the parent chain is 7 carbons long, so that's a hept. And then the alkene is located on carbon 3. So this is going to be 3 ethyl, 2, 2, 4, 5, 5, penta, and this is pink, pentamethyl, dash 3 heptene. And that's the answer. All right, finally we're done with that. Okay. Yeah, these are painful. I hate naming and practice. Like, I hate doing this. One of my least favorite things in organic chemistry. But we're done. All right, cis versus trans. Yes, the sexual identities of alkenes. Cis means that the functional groups or substituents are on the same side of the double bond, and trans means that they're on the opposite side. So look, if you see here, this is trans. The reason is because we have the double bond here. We have one that's above the double bond and one that's low, below the double bond. You have a functional group that's below the double bond and one is above the double bond, right? So if you imagine we have an imaginary line here, right? One's above and one's below. So this is trans. Trans is more stable than cis. Cis is when the functional groups are on the same side as the double bond. So, invisible line, both of them are below this invisible line of the double bond. So they are on the same side. The reason that this is less stable is because of hindrance here. It's basically crowded. That's the other word. And that's basically it. I don't know what else to tell you here. Yeah. Oh, and if this hydrogen's here, it doesn't count. It has to be a carbon or something else. That's not a hydrogen. All right, now onto the meat here. The more substituted alkene. Okay, why do you need to know this? The reason is because you need to know when we do E2 and E1 reactions, we are forming double bonds. The question is where does the double bond go when you make it? Right, so if I put this compound in a beaker with a base, and then you mix it up, blender noises, right? And they, they mix, and they're gonna form a double bond. Where does the double bond go? Is it just random? Am I just getting like one of those pinwheel things and spinning it, and choosing randomly where the double bond goes? No, there's a way to figure out where the double bond goes. You just don't put it randomly on the molecule. And the way we figured it out is with the more substituted alkene. Okay, the more R groups or branches an alkene has, the more substituted the alkene is. Therefore, the more substituted equals more stable. This is very important for elimination reactions like E2 and E1 because we can predict where the double bond will go in a reaction. So here, you'll notice that this is something called monosubstituted. This is because we have one branch coming off the double bond. This is monosubstituted or least stable. Then we have disubstituted because we have two branches coming off of this alkene, this double bond here. Disubstituted. This is trisubstituted, where we have three branches coming off this alkene. And tetrasubstituted, where four branches are coming off the alkene, right? Four different branches, the most stable. And that's it. That's basically it, yeah. I don't know what else to tell you guys. But next video is E2 reactions. So let's go! Until next time, later.